Hello guys, it's going to be day 91 of me coding every single day until I become a software engineer. Um, yeah, I got back a couple hours ago from driving 3 hours back home after Thanksgiving. So glad that went well. I didn't crash or anything. Uh, yeah, we're on day 91, still practicing for my interview on for my interview on Tuesday. So haven't really been hitting boot.dev. Though I probably need to at least try and do, yeah, oh, I have 10 left. Streak protection so I can keep my streak going. But yeah, I'll probably do this like tomorrow or something. But yeah, solving tons of hacker rank problems, tons of, well, not tons, but a good amount. I'm trying not to spend too much time on any one problem, just looking at the solution if I feel like I'm running out of ideas. But even then, I still like go back. I try and understand, what how the solution was derived and stuff. That takes me quite a bit of time, actually, surprisingly. So I haven't been making super fast progress, but I feel like I'm kind of understanding it. That I'm not just memorizing solutions. Like I'm writing these notes on every single problem. I saw this guy SWE Eric Coes. He gave that advice to write down your thoughts, and really good channel, by the way. So I've been doing that to try and make sure that I understand the solutions to some of these. And yeah, I would like to, if I had more time, spend time like actually uh, making sure I know my data structures like the back of my hand and implementing them from scratch and stuff. But I think my best bet with the amount of time left is to just do as many problems, see as many solutions as possible. So by intuition will at least be half decent, and I can have an idea of like how to solve a problem potentially. But maybe I'm just wrong. Maybe I should actually be, you know, uh, actually um, attempting to, find attempting to really understand this any one solution and stuff. But yeah, I don't know. I'm just kind of trying things at this point. But that's what's been happening. Feel free to give tips in the comments to see if we can solve this one problem. Given a square root of characters in a range of ASCII A to Z, rearrange elements of each row alphabetically, ascending. Determine if the columns are also in ascending alphabetical order, top to bottom. Turn yes if they are, or no if they're not. Rows are already in alphabetical order. The columns are also in alphabetical order. The answer would be yes. The only elements within the same row can be rearranged. They cannot be moved to a different row. This is an easy problem. Does not sound easy. Hacker is weird. I don't really like their problems. Like some of them are just kind of really weirdly written in comparison to LeetCode. I think I've expressed that sentiment multiple times at this point. But it means something's true, and I've seen discussions as well. People also criticize the way they write. But okay, so only elements in the same row can be rearranged. So we can't like move B and D. Apparently, you can only modify the rows. So we just need to return yes if everything is in alphabetical order. The constraints aren't even that big. Like, is this just a simulation? Can we just go through and if we see a number that's so, for example, say we had a or like HAC, then everything else is fine or something. And we're going through each part of the grid. So it's not a real grid, it's like yeah, this could still work. We look at each row. If we see like the ASCII value of H should be greater than the lowercase a. But yeah, if it should be lower than the next one. So like A, B, and C, like A would be lower than B, etc. H would be greater than B. So if you see greater than, then we just return no. So do that for each row, then we need to do that for each column. So with the way they're giving it to us, it's not like a real grid. It may be kind of annoying to go through the columns. So you go like for a high and range of the length of grid. So this is going to be each row. So we need to check I plus 1. So we don't want to go up to here because that's going to give us an index error if we go outside. So we want to loop from like the grid -1. And check if order of grid according to, oh, it is a real grid, it is a real grid. Okay, for J and range as well. So we're on the 0th row and we're on this character, so we're right here. If that is greater than the ord according to grid, I plus 1, I and J plus 1. That's greater than that we know. That's incorrect. So just return no. Otherwise, it's fine, and we just keep on going for each character in this row. Then we have to check each character in this row, each character in this row. And then we also need to do it column-wise as well. So can we do it like just in one pass so we don't have to go through again? So we can check this cardinal direction because this is going to be in order of grid according to I plus 1 because that's going to be the next column and its J value. So that's A. So that's, if it's 0, it's going to be 1, 0. Yeah, if that's greater than, so say if this was D and this was A, yeah. D would be greater than A, so it's greater than the word. Yeah, of grid IJ, so still the D. This is where we want grid. Grid I plus 1 to J. If it's greater than this, then return no. It's going to check. It's going to take the row first. It's going to take 0. It's going to check D and B. D and B would be no in this case, but say it was not. Say it was actually correct. Say it was D, E, A, B, C, D, E, F. And this was false. So now it's going to check D and A. If this is mixed up, it's going to return no. And it's going to keep going. It's going to check the E version. It's going to check the F and the B. It's not going to check F because that's the last one. Then it's going to go to the next one. It's going to check the A and the B. And the A and the A. It's going to check the B and the C. The B and the D. It's going to hear. Well, it's not going to check this. It's not going to check this last row. Okay, the problem is we're not checking this column. We need to check this column's F, C, it, E. Let's see if this even works for any of them, or if this is going to break. How did the last one return nothing? That makes no sense. So why is this returning yes? Or returning no? How is that even possible? Yeah, they're all lowercase, so I don't know how it's returning no. Like, okay, let's just print here and then the values of I and J to see where it's failing on this one. It's failing at the 0th column and this. What? How is it even possible? That makes no sense. So it checks if E is less than B, if E is greater than B. Well, yeah, this isn't. It's not alphabetical order, is it? Wait, what are we even? What? Determine if the columns Rearrange elements of each row alphabetically, ascending. Wait, I'm so confused. Like, are we trying to return whether or not? Oh, I completely misunderstood. That's what I'm saying. Like, it's so confusing. So we're supposed to be returning whether or not they can be rearranged in ascending order. Well, that's a much harder problem in my opinion. Yeah, I completely misunderstood the question, though I think it's very confusing the way they worded this. Because right here it's saying, oh, it's like describing that everything is already shorter right, so the answer would be yes. It doesn't really make clear that. Okay, I guess right here they say for each test case, it is possible to rearrange the grid alphabetically. Only elements from the same row can be rearranged. They cannot be moved to a different row. Okay, so this is obviously not a simulation. This would be a greedy algorithm somehow, because we're obviously not going to go through every single case here. So the question is, if we have something that is not correctly arranged, if something is not correctly arranged, how do we rearrange it? Or how do we know if we can rearrange it? So we can look at the D and the A. They're obviously not order. Okay, so we can swap these. So we have A, D, B. Yeah. And these are also not in order, so we would have to swap those two to be A, B, D. So if we get the ASCII values of each of these and we just sort them in each row, that would be the alphabetical. So F, A, B, C, D, E, F, G, H. So this is already sorted. A, B, C, D, E. So this is already sorted. Then we would sort this to be A, B, and the D would have A, D, E, then F, G, H. Then we can look and check again since everything is sorted. Since all the rows would then be sorted, right? We can look at the columns and see if they're sorted. So I think what we need to do is we need to create a new grid. So this might be useful later, but we need to create a new grid. That's basically the same as the current grid. So we're going to have length time. How do I do this? How do I create a grid? Want one array, and then we want just be This would be 3, right? So let's test this. Print length of grid. First line contains T, the number of test cases. Each of next T. First line contains N, the number of rows and columns of the grid. Oh. So I think we just need blank string times 3, right? Yeah, so it's going to be 3 blank strings. Oh, why is that taking so long to run? I thought you could do that. Apparently not. Initialize list with 3 blank strings. Python. I really should know how to do this, but oh, okay. Really should know how to do that. Times 3, right? Okay, so wait a minute. Maybe we want to for okay, so for S in grid, that's gonna be a string. For C and S, I'm gonna set new grid. Actually, no, we actually need the index. Or do we? No, I think we do. For I and length of grid. This really should be length of grid, by the way, not just a random number. So I is gonna be every row. For J in range of length grid, right? Let's just print out what each of these are because I'm so unsure what it will look like. I really should know this better, but what? You're gonna a blank space, a B, then an A, and then D, E, F. Looks so random. What? That makes no sense. Like, this is not a traditional grid, so yeah. Want to go through each character of the string and add the ASCII value to our new grid and sort the ASCII values. So maybe we actually want a list of lists actually. Don't worry about joining them later. What? Has initialize empty grid Python? Like, what the hell? List comprehension? Okay, I guess that works. Zero for underscore range length of the grid. Which honestly, we should just set that to be n equals the length of grid. Using it so much. Or underscore and range. Again. Looks like the length of the string is also going to be the same as n, so okay, so this should work. So maybe enumeration is just the best thing. Enumerate grid for C I and enumerates S. So we're going to get each string, then each character. The 0 is going to tell us the row it needs to go into, so the n index at the I character, right? I'm not sure if enumerate on strings gives you the index. I want to set it to the ASCII value of the actual character. I don't know, I'm struggling so much with this. Int object is not enumerable. Oh, it's supposed to be n s I C. Let's index out of range. How is one not linked to anything? Why is that happening? Um, wow, this was really annoying. I just wanted to go through every character and set it to be correct, but like, this turned to be unbelievably annoying. I've already been with 30 minutes. Okay, whatever. Obviously, I'm not getting this. Test cases are wrong. Problem and tests are not consistent. What is value? Oh yeah, he mapped each row to row that's sorted like I was thinking about doing just now. Got a sorted grid length. The length of the first row. So he's comparing if one string is gridded in the other. If one row is gridded in the other row. Okay, that would make sense. That would put them out of order. Yeah, that's a pretty clever way to do it. Yeah, a lot of this is just due to the fact that I'm not very good at working with grids. If I knew what I was doing here, I probably would have solved the problem already. I definitely had the right idea at least. So let's create a new sorted grid here. Sort string Python. Sake of time here, I'm just going to. I thought that would work. You might actually. Well, I don't know what is answering here. Can you do with the map? Okay, yeah, that's what I was thinking about. Sorted grid according to zero column. I don't know. The rows make sense. The columns make no sense. Because isn't sorted grid zero just the first row? Like, isn't that just ABC? See if his code works. It does indeed work. Okay, so I definitely was on the right track, but my poor ability to use a grid kind of maybe creating a new grid wasn't the greatest idea anyways, because that would require more space. But yeah, I'll look over this again tomorrow. This video is already super long. But thank you guys for watching. See you on the next one.